So this is the problem. So with that, let me go towards this. In fact, one of my colleagues, Krishnan, is doing some studies, and where they have used one particular model, and we have done a high resolution projection using this is atmospheric model, high resolution atmospheric model, driven by a coupled ocean atmospheric sea surface temperature given by a coupled ocean atmospheric model. And this particular model actually shows that the monsoon rainfall might decrease in the coming years. I have some confidence in this. Global temperature will increase. As far as temperature projections are concerned, I think the models are quite good, and you can rely upon that. So temperature is going to increase, but the monsoon rainfall need not increase. It can decrease due to various reasons. So we can ask an unorthodox question. Suppose we now ask, okay, if the monsoon is not necessarily increased, then can it really decrease? Can we get a mega drought due to climate change? This is another important question. So, is it possible? Some paleoclimatic records show that indeed there is such a possibility might take place. So in fact, you know this, I think many of here people know this, that there are records which show that on a millennium time scale, the North Atlantic temperature and North Atlantic temperature and the Greenland temperatures are closely related to variations of rainfall over Arabian Sea and in our region, which is related to the ITCZ. And so, in other words, whenever there is to be a cold climate over North Atlantic, there is to be a drought regime over Indian region, and vice versa. So this has been known from some, but in fact, there are examples of such 8,200 years ago. There was such an event which was studied by many people. In the Chinese people also studied this very much in the cave here. So there was a drought condition that over there also. Whole over Asia there was a big drought, and that appeared to be due to a lake burst here, freshwater lake burst, which produced a lot of fresh water in this North Atlantic. And this freshwater made the thermal circulation to become very weak, almost reverse. As a result of that, the surface temperatures are much colder. That seemed to be related to a drought in the monsoon. So these are known. So the question was then, how does the North Atlantic actual temperature affect our monsoon? This question was not very well understood. So recently we did some work with my colleagues, and then we found that indeed in the recent times, on multi-decadal time scale, the rainfall over in this region and the North Atlantic temperatures are reasonably well correlated. In other words, not only in millennium time scales, even on interdecadal time scale, North Atlantic temperatures, when they are cool, India will have drought conditions, and when they are warm, India will have above normal conditions. This actually happened. In fact, we have come up with a mechanism how it happens through the again tropospheric temperature gradient. It affects the tropospheric temperature gradient. So we can understand this mechanism by, at these two different regimes during last 50 years, there are some regimes where last 150 years, there are regimes where there is a warm and cold regimes in the North Atlantic, which if we look at the tropospheric temperature gradient, it turns out that the warm regime has more temperature here, and colder regime has a colder temperature. So the difference between them is positive, which means that during this, what happens in a sustained manner in the North Atlantic can affect the temperature in the northern part of India, and that can affect the north-south temperature gradient in the troposphere, not necessarily itself, and that will affect the monsoon. Because that is very slowly varying phenomenon. It will sustain this variation and sustain the monsoon in a drought state or in an enhanced state. And that is related to also what is called North Atlantic. By through modulation of the North Atlantic oscillations, we have gone through this some exercise of trying to identify that mechanism. And finally, what we can show is that the positive and negative phases of Atlantic multi-decadal oscillation or the North Atlantic SST can give rise to higher frequency or lower frequency of North Atlantic oscillations. These can change these extreme positions. This can affect the north-south temperature gradient in our region. That can affect the monsoon in a stronger region. So there is a mechanism by which we can do that. So we have an understanding. Can we use this? Can we use this to explain what might happen in the, happen to the monsoon due to climate change? Possible, but there are some issues. Let me come back to that. So, as the climate is changing, of course, we know that the polar temperatures are increasing at a rate which is at least twice as fast as the equatorial temperatures are increasing. So therefore, polar ice is melting, Greenland ice is melting. So all that melting of ice, the sea ice will not produce too much of freshwater sea level shift, but it will produce some freshwater, but not. But the Greenland ice is actually decreasing significantly, and the Greenland ice can produce a lot of freshwater in the North Atlantic. So, if the temperature in the north, in the polar region, northern polar region increases substantially, in the next few decades, there will be considerable amount of freshwater in the North Atlantic. If there is a freshwater, so much of freshwater, then what we can visualize is that the freshwater in the North Atlantic will produce, weaken the thermal circulation, because it will make the upper layer lighter, and the deep water formation will decrease, therefore thermal circulation will weaken. If thermal circulation weaken, the transport of heat to the northern region will decrease, warm waters will decrease, as a result temperature will decrease. And once the temperature in the North Atlantic decreases, temperature SST decreases, that will be related to weakening of the monsoon through the same mechanism that I mentioned. So there is a possibility that if there is enough melting of fresh water, then there will be a possibility of persistently weak monsoon. Instead of being a strong monsoon, we can go to weak monsoon phase, a mega drought kind of a condition. So we did some work with a model. We put a lot of pressure here and asked the model to predict what will happen with the monsoon. It turns out that this is a couple-dimensional coastal model, and we did two experiments with large amount of fresh water and relatively smaller amount of fresh water. Even this amount of fresh water is large compared to what we could actually get out of all the melting of the ice. But still, it is an experiment. Therefore, we used a little bit higher amount. And it shows that the thermal circulation can indeed decrease. This is a measure of the thermal circulation change in the at 30 degrees in the Atlantic. So, and if you look at the temperature and rainfall over India, rainfall over India will decrease in this particular model at least. And surface temperature will increase, the rainfall will decrease, and that is consistent with what we have been kind of proposing. So, there is a possibility that global change or the climate change can indeed drive monsoon to a mega drought kind of possibility. Whether it will happen will depend on some other non-linear interactions in the system, but this possibility cannot be ruled out. So then I think, how much time I have? 5 minutes? No problem. Okay, so then I am asking the question, have we really gone to a mega drought state already? And because there is a decrease in the rainfall over this period, we have already seen that it is decreased. Can we call this a mega drought state? If so, what is the driver for this? So we have been trying to understand the mechanism for this. Mechanism for this decreasing trend. I am coming back to the decreasing trend again, trying to understand what is causing this. To understand this, we looked at possible drivers. One of the drivers is, of course, North Atlantic temperature. But when you look at the interdecadals, in the recent years, see, there was a reasonable correlation in the past, but in the recent 2 decades, the North Atlantic temperature is increasing, monsoon is decreasing. So there is a problem, and we have still a dilemma. The North Atlantic doesn't seem to be driving this, and what else can it drive this? Then we looked at, okay, instead of North Atlantic, what else can drive? Of course, even Indian even the Indian Ocean SST can drive. The equatorial Indian Ocean SST can drive monsoon to either strengthen or weakening. What is happening to Indian Ocean SST? Indian Ocean SST is actually, this is indicated, this blue line is the equatorial Indian Ocean SST, and this is rainfall. Rainfall is of course decreasing. We have extracted the interdecadal component by using a singular multispectral